Hello everyone, my name is Ali and welcome to Computer Graphics. The criteria was to create a still life image either from real life or a video game using three different rendering techniques: physically based rendering from theory Pbrt, rasterization, and finally ray tracing. The plan for this video is to first show the three final rendered images for each, then break down all of the techniques used respectively in relation to the features implemented. Starting off with the Pbrt, I used a Pbrt plugin for Maya to directly output an image file rendered in Pbrt and create a .pbrt file in the rendered data folder to use later in the other renders. The camera position of this render is the most accurate of all of the three rendering techniques. This render used 500 samples per pixel to produce this image. Moving on to the Rasterizer Render, the code has the ability to read object files data such as vertices, faces, and edges. It can also output a TGA type image file once a frame has been rendered. The way the rasterizer works is that it first draws one point, then draws multiple different points towards the second main point, which looks like a line. Then finish drawing till the third point. Once all the 3 points are drawn, a bounding box is created, and using barycentric coordinates, the code fills up the area that falls inside the triangle. The barycentric code has additional code that implements backface culling along with a Z buffer to decrease render times. The models also have shadow mapping to render predetermined shadows. All of the rendering is being shown through a perspective camera and projection to view the scene from the reference image's perspective. Lastly, for the ray tracing render, the code has the exact same ability as the rasterizer code in terms of reading from an object file and outputting a TGA image file. Additionally to that, the ray tracer shoots out a tracer ray from each pixel. The amount of rays per pixel depends on the samples per pixel. The models can be assigned materials such as dielectric, diffuse, used for spotlights, Lambertian, and metal. Depending on the materials and their assigned colors, the ray behaves differently with each model. The model is loaded through a triangle renderer. There is aperture and focus distance to act as depth of field. The scene is rendered through a perspective camera with the same view as the other rendering techniques. Lastly, to speed up the rendering process, I implemented bounding volumetric hierarchy (BVH) along with multi-threading to use all cores and threads in the CPU. That is all. Thanks for watching.